Good morning, everybody. Here's a drive that we're going to be working on today. It's the Allen Bradley Ultra3000. This one won't power up. When I apply 120 volts AC to L1 and L2 here on these two terminals, the 7-segment display doesn't light up. First thing we want to do before we tear into this thing is we want to make sure we don't have no short circuits, and we can do that from out here on the terminal. Here's the DC bus terminals right here. This is plus and minus. Here's L1 and L2. Here's the motor connections, U, V, and W. So I'm going to put my black lead on plus bus, my red lead on L1, and we should have a good diode drop. There we are. 0.497. Let's go to L2. 0.502. Those are two good diode drops. Let's go to U, V, and W, the motor connection. There's 0.460. 0.457. Last one, W, 0.459. That takes care of that one side. Now we put our red lead on bus ground, or the minus right here, DC bus minus. Do the same thing. L1, we have good diode drop of 0.500. L2, 0.505. Here's U, 0.442. V, 0.442. And W, 0.442. So we have no short circuits on the power devices. Let's take this thing apart and we'll go inside and see if we can bring it up. But first, let me show you what it's doing. I'll put 120 volts AC here on the line, and we'll see if that 7-segment display doesn't light up. Let's turn it on. Does not light up when we apply 120 volts AC to L1 and L2. Let's turn it off. Get that unplugged there. We'll undo our line wires. We'll wait a little bit. Just charged up those bus capacitors in there. There'll be 170 volts DC across those bus capacitors. Thereabouts. That's 120 volts AC times the square root of 2. Give you roughly 170, maybe a little more. We'll come back in a little bit and start to take this apart. We'll see you shortly. There we go. That's been enough time for those bus capacitors to discharge. Now, first thing we want to do is take this faceplate off. Now, this side, the tab is broken on this side. You see that? But normally there'd be a tab that would latch into this slot right here. I'll show you on the other side. Right here's the tab. So let's push that out. Have the faceplate removed. Take the strain relief off right here. These are some long screws. There's one. There's two. These two screws off right here. side. Straight up. Here's the control board. Here's the bus capacitors I was talking about. Get this removed, we'll measure across those, make sure there's still no charge on those bus capacitors. We don't want to get ourselves lit up. So there's 4 screws here in the corner that hold the control board on. The first thing, before we take that control board off, we want to remove this plate right here. There's 2 screws holding that on. There we go. Control board off. Now this lifts straight up. You see a connector right here, and on each end of the connector are 2 dagger pins that help you align the pins on the bottom board, the power board, to the control board. So lift this straight up and it'll come right out. Here's the connector on the power board. What we have here, a little pointer. Right here, underneath this circuit, is the IGBT. And you can see there's the gate emitter connections. There's the power connections right here on that side. Here is a bridge rectifier. The line L1 and L2 are connected to that bridge rectifier. The AC is converted to DC with that bridge rectifier and filtered with these bus capacitors. What we're going to do first, after we get this power board off the heatsink assembly, we're going to check the switching MOSFET. That's this device right here. We're going to make sure that it's not shorted. If it is shorted, we'll have to make sure that the switching transformer hasn't been opened up on the primary side. If all that is good, we're going to replace these electrolytic capacitors. There's 3 here, 2 right there, 3 there, and 1 right here. These ones in the silver can, they're surface mount. They're a little bit more difficult to get out than this standard electrolytic capacitor with the feed-through leads. But we can do it. Done it 100 million times. We can do it. After we get it recapped, we'll power it up again and see if we brought this thing back to life. To get the power board out, we have to take these screws here that are mounted through the power devices onto the heatsink assembly. We have to take those out. there's two screws back here behind the bus capacitors that have to come out, and there's two screws here in each corner of the power board. There's one. Two. Turn this around so I can get these other ones. Three. Last one. All the screws that hold that power board to the heatsink assembly. The power devices have heatsink grease on them, so it's going to stick to the heatsink assembly. So you want to just lift it up a little bit to break that seal. I'll show you what I'm talking about. Now there's two slots in the power board over here that allow you to raise it up free of the control board mounts right there. You see these two slots? They come up through the control board mounts. There you go. There's that heatsink grease I was talking about. What that heatsink grease does with the power devices, you want a perfect mate of that power device to the heatsink assembly so that you have a good heat transfer. What the heatsink grease does is it fills the hills and the valleys in the metal of the power device. If you were to look at that power device under a microscope, you would see all the lands and grooves and imperfections of the metal. It's not perfectly flat, so that heatsink grease allows a good heat transfer from that power device into this heatsink assembly. Let's get this out of the way. Move this out of the way. I got me a little piece of cardboard here so I don't get that heatsink grease all over the place. Down here's the MOSFET that we're going to test. Here's gate to drain, gate to source. Let's turn this around here. Here's drain to source. Okay, there we got a good diode drop. That discharge and charging was the bus capacitors. So we're not shorted. We're not shorted, that's good. Let's flip this over. Let's measure those bus capacitors real quick. See what kind of voltage we have on there. Alright, we're good. Very tiny DC voltage on there that's not going to hurt us. Time for a recap. That switching MOSFET is good, not shorted. Now if it were shorted, we would check that transformer. Make sure that the primary hadn't opened up, but we're good. Okay, let me move the camera to a good position where you can see how we're going to change out these surface mount capacitors and that electrolytic capacitor over there. I get this camera moved out of the way and I'll be back in a little bit. When you're working with these surface mount capacitors. You can see we're very close to devices that we can melt with the soldering iron, like this switching transformer. Here's some capacitors right here, close to those. On the other side, again, the switching transformer. So just be aware where your iron is at all times, so that you don't melt this this other stuff. I hope I don't get my fingers in the way so you can see what we're doing here. But what I like to do is I'll add some fresh solder to the pad and the capacitor lead. There we go. Put a little bit more on there. And then I'll take and I'll lift that one side back. Okay. And then I'll go to the other side and heat up that solder lead and then push the capacitor back that way and just keep rocking it back and forth until you've got it fully released from the board. Don't burn your fingers. Here's one of them removed. There's that one is removed right there. We do the same thing for all the other capacitors, and once we get all the capacitors off the board, we'll clean it of excess solder and prepare it for the new capacitors. Now, I don't have any surface mount capacitors. I could order them if I wanted to, but I'm going to use just regular capacitors. Push that one that way. Just about that. And don't worry about melting the plastic on this capacitor. We're not going to use that capacitor again. That capacitor is going to go into the recycle. We got two removed. Set that one over there. I'm going to get a screwdriver, and I'm going to try and keep my fingers out of the way so you can see what I'm doing when I rock that capacitor back and forth. Heat up the lead with fresh solder. The fresh solder helps the old solder flow. Then just push it back. Heat up the other side. Push it the other way. And just keep going from one side to the other until you have the capacitor removed. There, we've got that one. There's three. You can see on the bottom, getting the camera, you can see the leads of the capacitor on the bottom. It has this little plastic spacer base that allows it to sit flat on the board. There's three removed. I'm going to remove the other 5 off camera to speed things up a little bit. Here's the 3 and the 2. But you saw how we did those 3 right there. That'll get you to starting on those other ones. This one over here, this will be the easiest one to remove. That's got leads that go through vias on the board. We'll just have to unsolder that one. Alright, I'll be back in a little bit when I get all those capacitors removed. Then we'll put some new ones on there. I like to take some denatured alcohol and a swab and clean up our work area before we add those new capacitors in there. This makes it look much nicer when you get done. Trying to stay in the camera while I show you what I'm going to do here. We have a standard electrolytic capacitor that I'm going to set down at this place right here. And what I do is I bend, I'm off the camera, stay in the camera, Peepaw. Bend the leads over and then cut the excess off. Just a little bit of the lead showing there, just like that. Do the same thing for the other side. Okay, now we're going to add some solder to one side. And that's going to be our anchor point. A little bit of solder on there. Tweezers. We set that down on there, heat up that one side, and then let that solder solidify. There we go. There's one capacitor. Now we solder the other side, then go back and add a little bit of solder to the original side. There you go. There you go. That's how you replace a surface mount capacitor with a standard electrolytic capacitor. Now these are polarized. This little line right here indicates the negative side of the capacitor. You don't want to put these in backwards. Okay? They will explode if you put those in backwards. Add some solder to one side. That's our anchor point. Set that down on there. Heat up the solder of that one side. Solder this side. Reflow the original side to make sure you got a good solder joint. Now here's the last one in this row. Get turned so y'all can see that. I'm going to try to do this backwards. Maybe you get a better look at it. Come in from this side, bend the leads, trim the excess. So now this is what you have. Solder one side. Solder. Change hands here with the soldering iron. So I got to come up underneath of here to get this side. Okay, and reflow the original side. There. I'm going to do the other capacitors off camera, and then we'll come back and we'll fire this thing up, see if we fixed it. Alright, see you in a little bit. There we go. All of the capacitors have been replaced on the power board. We're ready to fire this thing up. I'll put the control board down there. We'll apply 120 volts AC to the line input, and we'll see if that 7-segment display becomes active. Alright, now for the test. We're going to set the control board down onto its connector right there. Let's turn this up sideways so I can hook up the line. Make sure you don't put that line voltage in the wrong place. Okay, L1 is on terminal 3, L2 is on terminal 4. We'll double check that again before we put that 120 volts AC on there. There's terminal 4. Is good. L2 is good. Let me plug that into the power strip over here. Let me get you closer so you can watch that 7-segment display, see if it comes up. Here goes the 120 volts AC. There we go, look at that. There, we fixed it. All right. That's awesome. It looks like error 11. We don't have the feedback hooked up. We don't have the control going into it. We could look up error 11 and see exactly what it is, what the meaning of it is, but all we wanted to do was bring this drive back to life, and that's what we did. Alright, good job. Good job. Let's put this thing back together. Hot glue these capacitors so they're not moving around. There we go. That hot glue dry. Everybody's tight. Let's put the control board on top.